Hello, I'm Philip Mann, the Technical Director at Kappler. I recently was in a conversation with a customer and they had questions about cumulative permeation, which was an approach to measuring chemical and evaluating that breakthrough in a permeation test. Now, cumulative permeation has been around for quite a while. It's an approach that the military has used for many years. But in more recent times, that approach has also been incorporated into the testing methods that are contained within the NFPA standards. So I want to go back first and kind of present a little history of how permeation testing has changed through the years. So I have a chart here that shows how the original permeation testing was conducted from a method that was approved in the mid-1980s. And basically in this case, we had system detection limits, which is the sensitivity of that instrument measuring the permeation, and we evaluated that versus time. But the issue that we realized early on was that if two different laboratories ran two different system detection limits, they could get entirely different breakthrough times in those tests, and they both be considered valid. So at that time, the ASTM, who wrote that test method, decided to make a change. And when they made that change, they decided instead of measuring breakthrough at a system detection limit, they would measure breakthrough when the permeation rate reached a prescribed number. And in this case, that number was 0.1 micrograms per square centimeter per minute. And so we started reporting breakthrough based on the rate reaching that value. And what that did is that brought consistency or normalization across different testing houses and system detection limits. And that's why that approach was referred to as normalized breakthrough. And that approach was used by the NFPA in the early development of particularly the 91 standard, but then also the 1994 standard. More recently, as we've learned to adopt the cumulative permeation approach, we show another graph, and I must first point out that this topic was probably one of the most debated topics within our hazmat committee over the course of 2 or 3 years. And basically it said, rather than looking at that rate, we want to look at the total quantity of chemical that comes through a surface area over time. And that is that approach that the military had used for years in evaluating permeation of chemical warfare agents. So in this case, we take a pre-described number of 6.0 micrograms per square centimeter as the total amount of permeant that can come through in a period of time, in this case 60 minutes, and that is how breakthrough is now reported. Now, some people would say that number of 6.0 is arbitrary, but it's really not. If you look at the normalized rate of 0.1 in 60 minutes, you do that math multiplication and it comes out to 6.0. Now, I show here two permeation curves associated and how different chemicals and different fabrics can behave in different ways. The black curve is the more typical permeation curve that you would see. However, there is evidence in the industry to show that some materials will behave like the red curve behaves, where you'll get a peak and then it'll drop down over time. And so there was concern in the committee. They did not want to allow that red type response to exist. And so they also required that you evaluate cumulative at intervals within that 60 minutes. So at 15, 30, and 45 minutes, you also have to evaluate the total cumulative in that period, and that would prevent any material that behaves like the red curve. It would prevent it from being certified. Now, I know this is a lot of information, and I know it gets kind of deep, but I feel like showing this is the best and really only way to explain it. So again, that concept of cumulative permeation, the total quantity of chemical that comes through a defined surface area over a period of time, and in this case, 60 minutes for the NFPA certification. And this approach is now across the board in the new NFPA 1990 that does now incorporate 1991, 1992, and 1994. I hope this has been helpful. I'm Philip Mann, the Technical Director at Kappler.